Good day, viewers. I welcome you all to another class of math. Today, I will be showing you how to solve any question in a given limit. What are the things we are going to cover in this limit? So we are going to see the different properties of the limit and as well as the L-HOPITAL rule. So I'm going to limit myself to the L-HOPITAL rules because it's very powerful different types among the different types of the rules to solving any given limit question. Let's get started. If you are new to my YouTube channel, try to subscribe to it just for you to be aware of when I drop a new video. Let's get started. So the first thing we are going to do is the properties of the limit. Then followed by L-HOPITAL rule. L-HOPITAL rule. Yeah. So let's see the first properties of the limit. So the first property of the limit is the constant value. So we are given a constant value and you have to find the limiting value of any constant value. So if you limit any constant value, it still also equals to the constant value. So because constant value doesn't have any function, you must limit a particular functions based on the given function. Yeah. So you are given a given function. That function must have the corresponding element that you're asked to limit. So before you can insert the given value. So if you have the first one, the limiting of any constant value, suppose we are given x tends to any number. So let me just use a as that number. And we have this k. You see that x and k, they are not the same. So x and k are not the same. So this k here serves as the constant value. So we have to find the limit of any constant value. So it still also equals to the constant value. And suppose we are given the limit of x tends to 3 of, let me just use 5. So you have to limit this particular 5. So 5 doesn't have x. So because of this doesn't correlate together, so which means that 5 here is still the same thing as k. So we have the answer to be equals to 5. So you limit the any constant value also equals to the constant value. So don't write 3 because there is no x here. So if there is x here, then we insert the value of x. Then you get it. So the second limit we are going to consider here is the limit of positive or negative values. So we are given the limit of positive or negative value. So to do that, it's very simple. So the limit of, let's say, limit of x tends to a, then if this is f of x plus or minus g of x. So to do this, just separate these two and that is all. So by separating this, then we have the limit of x tends to a. So you take f of x first, then plus or minus the limit of x tends to a and g of x. So let's see it in example how you can solve a given question in a limit having positive or the negative values. So don't forget, I've done the constant value before, so I might apply the first rule, which is the constant rule. So if you are given a question like this, let's say example 2, if you have to limit x tends to minus 1. So the value of this one can be anything. It can be positive, negative, even it can be 0 and others like that. So given this particular function, you're asked to limit, let's say you have x squared plus 3x minus 1. So to limit this, I've combined both positive and negative. Here is positive and here is negative. So to do that, you can separate this limit. So we have the limit of x squared at x tends to minus 1 plus, here is positive, then the limit of x tends to minus 1, and here we are going to have this one to be negative. The limit of x tends to minus 1 of 1. So you not write negative 1 again because I've taken that negative outside the bracket. So you just leave it as 1. So here, whenever you have x, you replace x with negative 1. We have minus 1 squared plus. So, okay, sorry, I'm going to put 3x here. So whenever I have x here, you are going to replace it with negative 1. We have 3 to bracket of negative 1 minus. So now, you cannot write negative here because this 1 doesn't have x. So you leave it as 1. So it's not that because there is negative 1 here, you write negative 1. Because there is negative here, that is why this negative comes with this one. So you write this one again. So it's not that because this one is having negative 1. So here we are going to have minus 1 squared, it means 1, minus this multiplied by this, plus multiplied by minus, that is negative, 3 multiplied by 1, that is 3, then minus 1. So the final answer for this one equals to, if this cancel this, then we have negative 3. So you limit these particular functions to what? To negative 3. So the given function here is finite function before, so it's infinite function before, then you limit this particular function to x tends to negative 1. So this value is continuous. This particular function is continuous, but you apply the limit just to reduce just to reduce the function and approach a given value. So this one means approach. So you want to get to a certain stage. You want to stop at a particular point. So that is what they mean by the word limit. So now the next rule is the multiplication and the division rule. Okay, so we are giving this particular limit. So the limiting value of x tends to a, and giving f of x dot g of x. So to do this is very simple. So just separate these two limits as well. We have the limit of x tends to a, and here is f of x dot the limit of we have g of x, g of x at x tends to a as well. So that is what we are going to do. And let's see this one in example as well. The limit relating to the multiplication. So the limit of multiplication, you are given this example. Let me call this one example 3. So you have to calculate this particular limit. Limit at x tends to 2 of L is 2x. Yeah, let me just leave it as 2x. So because there is a multiplication operation between these two and this variable. So to do that, we can have this as the limit of x tends to 2 of 2 dot, because there is a product operation between these two, then the limit of x tends to 2 of x. So I told you that the limit of any constant value equals to constant value. We're going to have 2 dots. So this dot means multiplication, and this one is also 2. 2 here, replacing this x with 2, we are going to have 2, and 2 multiplied by 2, that is equals to 4. So the next limit is division. So given the limiting value of x tends to a, open bracket, let's say we have f of x divided by g of x. So what they are going to do is just separate this limit of f of x at x tends to a divided by the limit of x tends to a, and there here is g of x. So that is what the rule says. If you are given this particular limit, just separate it, then you get the final answer. Okay, let's see the sample. So given the limit of x tends to 5, and here is x squared divided by 1 plus x. So to do this, you separate this given limit by putting this here, then divided by whenever you have x, you replace x with this 5. And we are given 5 squared divided by 1 plus 5. And 5 squared here is equivalent to 25 divided by 1 plus 5, that is 6. So you limit this particular function to 25 divided by 6. I think I've given you like 5 different properties of limit. So let's see another one. So if you are given the limit of a power, or let me just say the limit of a root. We are given a root limit. So how are we going to do that? It's very simple. So let me just call it another properties of the limit. So given the limit of x tends to a, we are given f of x. Okay, let me just say nth root of f of x. You know, this is nth root. So whenever you have something like nth root like this, so let's say you have nth root. So the nth root can still be 1 divided by n. Just like if you have root 2, so root 2 can be still equals to 1 over 2. If you have root of 3, cube root of 3, so it can still be 1 divided by 3. So whenever we are given this particular limit, so you limit this thing to f of x raised to the power of 1 divided by n at limit approaches this particular value. So which means whenever you have the function of x here, you replace that f with this one, then you let this one to be raised to power if you wish. So if you wish, let's see how if you wish can come to 2. Then let's say example here, if you ask to limit this, let's say x tends to 2 as well, then you have root of x squared plus 1. So to find this, whenever you have x, just replace x with 2. So here we have 2 squared plus 1 equals to the square root of, what is 2 squared? 4 plus 1. And 4 plus 1 equals to root of 5. That is the answer. So you can't leave it as root of 5, but this root, whenever you have a root like this, what is at the back of this list is 2. So we call this one square root. So then we can still have it as 5 raised to the power of 1 over 2. That's why I said if you wish. So come to the end of the properties of the limit. Now let's move to the L-HOPITAL rule. I mean the most powerful different types of the limit. Because we still have some other 2 types of the limit, but if you are applying those 2 types of the limit, then yeah, it's worth it, but it might not be efficient sometimes. So that is why L-HOPITAL rule is the father of all the other types of the rule. So we call this one L-HOPITAL rule. L-HOPITAL rule. We can call it differentiation rule. Yeah, differentiation rule or the L-HOPITAL rule. That is, those particular functions we are going to be differentiating them. How and when to differentiate them. So let's say you insert the particular value of x into the given function, and the denominator and numerator have 1. So let's say the value of numerator is infinity and the denominator is also infinity. So that particular value you got is undefined. So to do that, we are going to apply the L-HOPITAL rule, or both numerator and denominator are 0. So when we have something like that, then we're still going to have it, we consider it as undefined. Then to redefine it, we apply the L-HOPITAL rule. So that's why I'm going to give you this take. And suppose you still redefine it, you differentiate that particular function and you still insert the value, then you keep differentiating until you get to a value that is not undefined. Okay, consider this simple logic. Let me just call them the rules. Let's say let this symbol be any number. Let me just call it any number. Yeah, so the any number here can be 2, can be 3, can be any number, even it can be 0. Yeah, 0 is still any number, but not infinity. So, and suppose this symbol means infinity. Yeah, so we call this one infinity symbol. So just like you bend it, horizontal it, we call it infinity symbol. So what are the things that connect this infinity and any number together? So suppose you have this any number divided by any number, where this any number is 0 and 0. So I'm not talking of other number. So if these two are 0, then we have this thing to be undefined. And when this as well equals to infinity divided by infinity. So that is, if we have infinity by infinity, we are going to have it as undefined, and this we are still going to have it to be undefined. But let's say you have any number divided by infinity, this equals to 0. And if you have infinity divided by any number, so this equals to infinity. If you have infinity minus any number, this equals to infinity. So if you have any number plus infinity, also equals to infinity. And whenever you have infinity multiplied by any number, it still goes to the infinity. So let's hold all these important points because I'm going to be using them during the course. So this in this, we have 0. Any number divided by infinity, that is going to be 0. Suppose we have 2 divided by infinity, that is going to be 0. That is the only exception. But if you have something like this, then you are going to redefine that particular function. But if you are solving a given question, then you arrive at this, don't redefine because this one has a defined value. But for this one, it doesn't have defined value. Now let's see different examples we can use to clear our doubt on these L-HOPITAL rules. So suppose you are given this first example. Let's say we have the limit of x tends to 0 into bracket of 1 minus x squared divided by x let's say divided by x squared as well. So we are given this kind of limit. So I've combined two different properties. Here is negative and here is division. So to do that, whenever we have x, so we are going to replace x with 0. Whenever we have x, we replace x with 0. So let me just say we have 2 here. We have 2 here, so we're still good to go. Okay, by putting this value, so we are going to have this one to be 1 minus 0 squared divided by then 2 into bracket of 0 squared. So here 1 minus 0 squared, that is still 1. Then 2 multiplied by this, that is going to be 0. But this is any number and this is 0 as well. I didn't give this. But if you have any number divided by 0, so it's still going to be infinity. So you can get infinity. Once you get infinity, then you are good to go. Okay, let's say you have another example like this. Number 2, let's say you have the limit of x tends to 0, open bracket. If you have this one to be x squared minus 4 divided by x minus, let me say at x tends to 2 and here is x minus 2. So you put the value of this x tends to 2. So whenever you have x here, we replace it with 2. So here we have 2 squared minus 4 divided by 2 minus 2. And definitely this is 4 minus 4, that is 0. And why this one is also 0. So this kind of thing, so it's undefined. So we call it undefined. To redefine it, we are going to differentiate this. Now, differentiating this, so this is x squared. If you differentiate it x squared, you are going to have 3 to be 2x. But this is constant value. Differential of any constant value equals 0. We are not limiting first. So you firstly differentiate. Differential of this constant value equals to 0, not limit. It is the limit of any constant value that is equals to that constant value. So now we differentiate this one as well. Differential of this x is still 1. Then you can now limit at x tends to 2. So if you limit this, so whenever you have x, we replace that x with 2. Then we have 2 multiplied by 2, that is 4. So which means the first approach, you substitute this, then you get 0 by 0, which is undefined. Then you redefine it by differentiating it. So as far as you are differentiating a particular limit, we are dealing with L-HOPITAL rules. So you differentiated this thing once, then that's why you apply for. But in some cases, even after you differentiate, you still get undefined. So how are you going to do that? Then you keep redefining, you keep differentiating until you get to the final stage. So let's see another example. Another example here is, if you are given a particular limit like this, limit of trigonometry, let's say about 2, if you are asked to limit this at x tends to 0 of sine of x. Okay, let me change this one to theta. Don't let me stick to one variable. So I can change this to theta of sine theta divided by theta. So to do this, we are going to put the value of theta at equals to 0. Here is sine 0 divided by 0. But sine 0 is still 0 divided by 0. So definitely this one is undefined. But to redefine it, we are going to differentiate it. But differential of sine theta equals to cos theta. And differential of theta, that is 1. Yeah. Then you limit this at x tends to 0. So if this theta equals to 0, we are going to have cos 0 divided by 1, and cos 0 equals to 1. Yeah. Cos 0 equals to 1. Okay, another example here is, let's say you have the limit at x. If this limit at x tends to, the limit at x tends to 0, open bracket, here is 1 minus x divided by, let me just have this one to be x squared. 1 minus x squared divided by x squared. Yeah. So let's see how to solve this limit. 1 minus x squared divided by x squared. So the first thing I'm going to do is by inserting the value of the limit. Yeah. So if you insert the value of the limit, what I'm going to get, we have this as at x tends to 0, we have 1 minus 0 squared divided by 0 squared. Here we have 1 divided by 0, that is undefined as well. But let's say you are given another example like this. Okay, let's say limiting value of x tends to 0, open bracket, 1 minus x squared. Yeah, so this one I want to give before, divided by 1 minus x. Okay, 1 minus x. So if this particular limit is given, so to do this, whenever you have x, you are going to replace it with 0. Here we have 1 minus 0 squared divided by 1 minus 0, and this automatically 1. So another example here is, let's say you have the limit of x tends to 0 at x squared divided by 1 minus x at 1 minus x. Although let me give this, let me just give the example relating to exponential. Okay, let's say you have the limit at x tends to 0 of exponential 2x minus 1, everything divided by x squared. Yeah, so how can we solve this? So whenever we have x, we are going to replace that x with 0. Here we have exponential 2 into bracket of 0 minus 1 divided by 0 squared. But exponential 0 here divided by 0. Exponential 0 is 1. And 1 minus 1, that is 0 divided by 0. So this is undefined. Though to redefine it is very simple. Just keep differentiating until you get to the final answer. So here, when we differentiate 2x, differential of 2x, so you take these 2 back, that is 2 exponential 2x, but differential of constant value equals to 0, right? Then let's differentiate this. So we have 2x, differential of x squared, that is 2x. So which means we still limit this at x tends to 0. So whenever we have 0 here, what are we going to do? So we are going to have 2 into bracket of 2 exponential, here is 2 into bracket of 0 divided by what of this? So 2 into bracket of 0. So now multiplying this, so you know everything here becomes 0, right? Exponential of 0, that is 1. 2 multiplied by 1, that is 2. Then 2 multiplied by this, that is 0. And 2 divided by 0, that is infinity. Okay guys, praise up. So today I'm going to stop here as far as the limit is concerned. So I'm believing you guys are at this point should be able to familiar with what you call the L-HOPITAL rules. So let's do a quick recap. So in L-HOPITAL rules, so just like the differentiation rule, if you are given a question, you keep differentiating. So when you insert the value of the limit, then you keep differentiating. So when the value, when the answer you get is still a redefined function, you keep differentiating until you get to the final stage. Thank you very much. Or if you are new to my YouTube channel again, please subscribe. Subscribe. That is only how you can encourage the tutor. Subscribe, like, comment, just for you to be aware of when I drop a new video. So if you have any question to ask, drop it in the comment section below. So I will see you there. Thank you. Bye bye.